are you? My name is Anna Tim Benson. Welcome back to my channel. I am doing this LeetCode problem set, and today is problem number 41, and the solution is going to be in Python, but 41 is first missing positive. So I have read through this a couple times. I started about 6 minutes ago, and I don't know if I'm deducing this far less than what it needs to be, but let's go ahead and read through the question, and then I will talk through what I'm thinking in terms of writing a solution. So without further ado, this is number 41, first missing positive. Given an unsorted integer array nums, return the smallest missing positive integer. You must implement an algorithm that runs in 0n time and uses 0, 1 auxiliary space. So they give you the three examples, and the two constraints. So I'm kind of thinking this is like a solid 3-step plan. And I actually brought my little whiteboard here. I was going to say I thought I got my little tab open for my whiteboard app, but I actually hate drawing on the computer. So what I'm thinking is for Jojo, do not. We start and basically we just start the step 1 where we arrange an array so that the nums I is at index I. And then step 2, looking at this example, if 1 is in the array but 2 is missing. Yeah. So then I think we should then do, when we find the first index I, where nums I, so here, let me write this out. So, okay. My little whiteboard I got from the Dollar Tree, you guys. Amazing. So my first step is to rearrange array. At nums, when I say nums I is at index I. So, and then from here, like this, we will go into this finding, what I say, the first index. Where nums, my hair just got stuck in that somehow. Nums I. So 1 plus I. Yeah. So that's how I want my next step to go. So in terms of this flow, that's what I'm thinking. And then basically just return all the elements to the correct position afterwards. So I don't know if I'm just deducing this into a simple 3-step process or what I'm doing, but in my brain, it should work. And on my whiteboard, it should work. And this is I'm paraphrasing this a lot, but we are doing our best with what we got. Right, Jojo? Put that over there. Okay. So let's start by defining the length of nums. And then jump into step 1. So, and I'm just going to make sure I read this again. This is going to be the 6th time. So given an unsorted integer array nums, return the smallest missing positive integer. You must implement an algorithm that runs in 0n time and uses 0, 1 auxiliary space. So I'm really trying to compact this. So I'm going to do a for while loop for the first step. So basically when the index is in range, and I guess while 1 is something like a nums index. Okay, I'm just going to start here. So I'm going to say for I in range n. While 1, I wonder if I could do a couple indexy things here where if 1 is greater than or equal to nums I, which is greater than or equal to n. This is going to get a little wordy, I think, because we want that index minus 1. Can I say and? And nums I minus 1. And then I can just say nums. So that way we can do a nums I minus 1 nums I equal to nums I, so that's that same index. And then I think I want to do that decrement again. So the nums I minus 1. Okay. So that will rearrange the array so that nums I is at index I, which is how I want this to start. And I also think will coincide with this requirement for space and time in a perfect world. Because what I'm about to do next is do another loop where we have a for I in range. And this is going to be what I was talking about with that second. So we're going to find that first index I, where nums I is. So we're going to say if nums I, exclamation point. What did I say on here? Okay, I'm going to hope that that's right, because I do want it to return the index plus 1. This should be right. And then I can just do return I plus 1. So then all we have to do is return n plus 1. So in theory, this is a simple 3-step system, but we kind of, given this structure, we're trying to populate. Guys, my brain is not working today for words. I'm really struggling to get these words out. I told you my 3 steps. Let's go ahead and run it. Okay. We're 15 minutes in. Let's submit this. I'm waiting with bated breath. Okay, not as well as I wanted it to be. Only 48%. I'm sorry, 46%. Sorry, 46 and 46. So while this is a solution, probably isn't the best solution. I definitely think I could have streamlined something around here now that I'm like thinking about it. I mean, that was hard. It's hard because it's hard for the optimization part of it. Because I really thought in my head I had really like kind of pared it down. But memory and runtime, almost 50%, not entirely. And I'm sorry if you guys, if I didn't make complete sense. I've been kind of just struggling to get my head in the game today. So I'm gonna hopefully crank out a few more problems and get my brain back to where it needs to be. But in the meantime, I'm going to put this code in the GitHub repo link that I have in the video description box. And you guys are more than welcome to fork and clone, make it better, make it worse, learn something new, have some fun, and I'll see you guys in the next video. Thank you guys so much for watching, and have a great rest of your day.